Hi everyone, in this video we're going to be going over the last chunk of derivative rules that we need for this chapter. So we're going to be learning derivative rules for trig functions, exponential and logarithmic functions, and inverse trig functions. So we're going to go through some rules and then we'll do a couple practice problems for each. So the first ones we're going to talk about are trigonometric derivatives. So when we use this notation, we're doing the derivative with respect to x of sine of u. Now this u is just going to account for any chain rule we might have going on, and I'll talk about that in a second. So the derivative of sine is going to be cosine. So we would have cosine of u times du dx, or the derivative of u with respect to x. And so here's what's happening here. If we were to take the derivative with respect to x of sine of x, in this case there's no chain rule because this is just an x. So our derivative would be cosine of x. Now, if this were to look like the derivative with respect to x, let's say sine of 2x, now we know we've got some chain rule going on because of this 2x. So the derivative of sine is going to be cosine. And we know when we do chain rule, our inner function stays the same at first. So we have 2x, then chain rule tells us we have to multiply by the derivative of that inner function, which in this case is 2. So that's why here this u is representing the 2x, this du dx is representing that derivative we have to do for chain rule. So hopefully that kind of clears up some of the notation, but if you have questions about it, please ask when we start class. Alright, so now, derivative of cosine, we have negative sine of u, and we're always going to have that times du dx. The derivative of tangent is going to be secant squared of u times du dx. Now I'm just going to follow along here. The derivative of cotangent now is going to be opposite. Instead of secant, we're going to have cosecant squared of u times du dx. Secant is going to be secant of u times the tangent of u times du dx. And then for cosecant, we're going to have opposite. Instead of secant, it's going to be cosecant of u times cotangent of u times du dx. So you can see every time we have one of the cosecant, cosine, or cotangent, our sign is always going to be negative in front. So let's look at a couple examples. My first one, f of x equals cosine of 3x, and I'm asked to find f prime of pi over 9. So the first thing I'm going to do is find f prime of x. I know the derivative of cosine is negative sine. So I have negative sine. Now here I have chain rule. So my inside is going to stay the same as 3x, and then I'm going to multiply by the derivative of that 3x, which is 3. So my derivative is negative 3 times the sine of 3x. So now I'm going to plug in my pi over 9. F prime of pi over 9 is equal to negative 3 times the sine. Well, 3 times pi over 9 is going to give me pi over 3. So now I have negative 3 times sine of pi over 3. Is root 3 over 2. So my derivative is negative 3 root 3 over 2, which looks like choice E. Alright, my second example then looks like I'm going to have we're finding a general derivative, but I can see I've got product rule here because I have my first function is x squared, and then I have sine of 2x. So I'm going to use product rule, and I know I'm going to take my first function, x squared, times the derivative of my second. Well, derivative of sine is going to be cosine, so I'm going to have cosine of 2x, and then I have to multiply by the derivative of my inner function, which is going to be 2. plus, now I have sine of 2x. I'm keeping that second function the same, and I'm multiplying by the derivative of my first, which is 2x. So if I'm going to simplify that a little bit, it looks like I have 2x squared times the cosine of 2x plus 2x times the sine of 2x. We'll see, hopefully one of those matches my choice. Now, I'm seeing it looks like they've factored out that 2x, so I'm going to go one more step here. Factor out a 2x from each term. So that means in this case I have x cosine of 2x plus sine of 2x. Now let's see. It looks like the order is just a little different, but means the same here. So I have 2x, there's my sine of 2x term, and my plus x cosine of 2x term. So again, my choice is E. Okay, next ones we have our exponential and logarithmic functions. Now I want to change this a little bit. Instead of being 2 to the u, I'm going to make this the derivative of a to the u. And I'm just going to make a note that a is a number. Like that could be 2 to the u or 3 to the u, but I'm going to use a to generalize this. So then my derivative here is going to be a to the u times the natural log of a, and then times du dx if I have any chain rule going on. For e to the u, this is really nice. Its derivative is just e to the u itself times du dx if we have chain rule. Now for this one again, I'm going to change this. Instead of being log base 2, I want that to be log base a of u. So now my derivative is going to be 1 over u times the natural log of a times du dx. And then for the derivative of natural log, I'm going to have 1 over u times du dx. So let's look at a couple of examples here. My first one is f of x equals e to the 2 over x, and we want f prime of x. So I'm going to do a few things here. So really what we have is this. E to the 2 over x. And I'm, for my purposes here, going to make that e to the 2x to the negative first, because that's going to help me a little bit when I go to differentiate this. So when I go to find my derivative, I know the derivative of e to the x is just, or e to the whatever, is just e to the whatever. In this case, it's 2 to the x minus 1, to the negative first, I should say. And then I'm going to take the derivative of that exponent. So I'm going to use power rule here. So I have negative 2x to the negative 2. So let's see what this looks like. I know this is really e to the 2 over x times, let's see, it's negative 2 over x squared. So if I simplify this, I have negative 2 times e to the 2 over x all over x squared. And let's see, this would be an equivalent expression. I have the negative 2 over x squared times my e to the 2 over x, so choice D. All right, now for number 2, we have a natural log here, and you can see I've also got some chain rule. So if I do f prime of x, first I deal with my outside function, which is the 2. So I have 2 times the natural log of x. When I subtract my exponent, that just becomes 1. So I've dealt with the outside. Now I have to do the natural log of x, which is just 1 over x. So my derivative is 2 times the natural log of x over x. So now if I'm going to find f prime of the square root of e, I have 2 times the natural log of the square root of e all over the square root of e. So let's think about this. We know that the square root of e is the same as e to the 1/2. So I have natural log of e to the 1/2. I also know that the base of the natural log is e. So this is really asking me e to what power gives me e to the 1/2. So I know this expression just simplifies to 1/2. So I have here 2 times 1/2 all over the square root of e, which is just 1 over the square root of e, which is going to give me choice D. All right, last batch of derivatives here is our inverse trig derivatives. And I know this is a lot. Again, I know it's a lot of memorization, but we'll have time to practice and work with all these rules in class. All right, so derivative of inverse sine is going to look like this. It's going to be 1 over the square root of 1 minus u squared times du dx. Now, the nice thing is the inverse cosine is just going to be the opposite of that. Sorry, that got smushed in there a little bit. Derivative of my inverse tangent is just 1 over 1 plus u squared times the derivative if there's chain rule. And again, now my cos here are just the opposite. Nothing changes except the sign. So 1 over 1 plus u squared times du dx. I'll move my finger out of the way. Derivative of inverse secant. Now this one's a little bit involved here, and I think there we go. It's going to be 1 over the absolute value of u times the square root of u squared minus 1 times the derivative of u with respect to x. And the last one is just the opposite of that. So negative 1 over the absolute value of u times the square root of u squared minus 1 times the derivative if we have chain rule. Okay, so for a couple examples here. My first one, f of x is the inverse sine of x cubed, and I need to find the derivative. So I'm going to start inverse sine looks like this. So I have 1 over the square root of 1 minus, now in this case my u was my x cubed. So I have x cubed squared. And then I'm going to take the derivative of u with respect to x, which is 3x squared. If I simplify that, I get 3x squared all over the square root of 1 minus x to the 6th. And that would be my derivative. Last example is here with inverse secant. Again, this 2x is what we refer to as our u here. So now I have dy dx equals, see, inverse secant is 1 over our absolute value of u, in this case is the absolute value of 2x, times the square root of u squared, so 2x squared, minus 1 times the derivative of u with respect to x, which is times 2. Now, there's a few things I'm going to do here to simplify. I'm going to put this 2 on top. Now, when I look at my absolute value of 2x, since 2 is positive, I can just pull that out front. And I'm going to leave my absolute value of x because I need to control that sign. Now, inside, I'm going to simplify this. So I have 4x squared minus 1. And the last thing I'm just going to do is cancel these 2's. So my derivative is 1 over the absolute value of x times the square root of 4x squared minus 1. So again, I know that's a lot in terms of memorizing all these derivatives. It's probably going to be very helpful here to do flashcards to help you practice, and we'll be working through some problems in class. So thanks for sticking in with the video, and I'll see you back in class.